Hello and welcome to lecture number 3 of this course. Today we will be learning about Java operators and we will also discuss about binary to decimal and decimal to binary conversion. So let's start today's session. Okay, so at first let's try to understand what are binary numbers and what are decimal numbers. So decimal numbers are generally the numbers which are made using the digits 0 to 9. Suppose 213, this is a decimal number. 129, this is also a decimal number. But what are binary numbers? Binary numbers are made up of only two digits, 0 and 1. 0 and 1. Suppose 10101110. This is a binary number. 001100110. This is also a binary number. So those are decimal numbers and those are binary numbers. Decimal numbers are made with the digits 0 to 9 and binary numbers can contain only two digits 0 and 1. These are also known as bits. Now suppose if you want to convert 21, this is a decimal number, into a binary number. How you will do it? Okay, so at first you need to start dividing it by 2. Why 2? Because in binary numbers there can be only two digits 0 and 1. So if I divide 21 by 2, the quotient will be 10 and the remainder will be 1. Again, if I divide 10, quotient will be 5, the remainder will be 0. 2 2s are 4 and remainder will be 1. 2 1s are 2 and remainder will be 0. How long we will do this? We will do this until and unless we reach 1 as the quotient. After we have reached 1, then we will check the result from the lower side to the upper side. So the answer will be 10101. 10101. Now let's try another example. Suppose I want to convert, just a minute, let me adjust the screen. Suppose I want to convert 12 into its binary form. Suppose I want to convert 12 into its binary form. How will I do it? 12. Again, what I will do, I will start dividing it by 2. 2 6 are 12, 2 3s are 6. Here the remainder will be 0. Here the remainder will also be 0. 2 1s are 2 and the remainder is 1. So what will be the answer? Again, from lower side to upper side, the answer will be 1100. Alright, so this is how we convert decimal numbers into binary numbers. Now, if I try to do the reverse thing, what will happen? If I pick this number 10101, so this is a binary number, and if I convert it into its respective decimal number, what I will do? At first, we will map the numbers to their respective positions. This is the position 0, this we will take as position 1, this we will take as position 2, this is 3, and this is 4. And we will write 2 as the base. 2, 2, 2, 2, and 2 also over here. So, but just a minute, let me write it properly. 2, 2, and so what we will do? Here we are writing 1 into 2 to the power 4, 0 into 2 to the power 3, 1 into 2 to the power 2, 0 into 2 to the power 1, and 1 into 2 to the power 0. How we will write 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So 2 to the power 4 is how much? 2 to the power 4 is 16. 16 ones are 16 plus 0 into something is 0. 2 to the power 2 is how much? 4. 4 into 1 is 4 plus 0 into something again 0 plus 2 to the power 0 means 1. Anything to the power 0 is 1. 1 into 1 is 1. So 16 plus 4 is 20. 20 plus 1 is 21. See, we got back the number, decimal number, that is 21. So 10101 is 21 in its decimal representation. So again, if we try to do with another number, suppose 101, what will be the output? What will be the result if we try to convert it into its decimal form? We will write 2 to the power 0 here, we will write 2 to the power 1 here, we will write 2 to the power 2 over here, because this is the zeroth number, this is the first number, and this is the second number, or the zeroth bit, first bit, and the second bit. So again, what we will do, 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So 2 to the power 2 means 4, 1 into 4 is 4 plus 0 into something is 0 plus 2 to the power 0 means 1, 1 into 1 means 1. So 4 plus 0 plus 1 means 5. So 101 is the binary representation and its decimal representation is 5. Let us check 5. If we divide by 2, 2 2s are 4, the remainder is 1. 2 1s are 2, the remainder is 0. So what is the answer? 101. We always go from the lower side to the upper side, so the answer will be 101. I hope it is clear now. So this is how we convert from binary to decimal and the reverse, and we go back from decimal to binary. All right, so this was important because today we will be discussing about bitwise operators. So at that time you need to understand how the bitwise operations take place, and without these binary numbers you won't be able to understand that. So let's move on to the first topic of today's class, operators. So what are operators? Operators are used to perform operations on variables and values. So if we take this example, int x equal to 100 plus 50, there are two operators over here. Here there is an assignment operator. The equal to sign is an assignment operator, and the plus sign over here is an addition operator or arithmetic operator. So 150, these are the two values. The arithmetic operator, that is the addition operator over here, is adding these two values. And what is the result? The result is 150. This 150 value is getting assigned onto the value x, onto the variable x. So 150 value is getting assigned onto the variable x. And who is doing that task? That task is done by the assignment operator. And what is the assignment over here? Equal to sign is the assignment operator over here. So what are the different types of operators present in Java? The arithmetic operators, assignment operators, comparison, logical, and bitwise operators. We will discuss about each of them in the next few slides. But before moving on to the next slide, let us discuss about something else. Suppose I have written int x equal to 100 plus 200. So what will the value that will be stored on x? The value 300 will be stored on x. Now, if I write int a equal to 100 and int b equal to a plus 200, what will be the value that will be stored onto b? Again 300 will be stored. Why? Because here we are performing addition operation on a variable, that is a, and on a value, that is 200. But this variable a is containing the value 100, so indirectly 100 and 200 is getting added, and the value 300 is getting stored onto the variable b. So this is what we were doing, the addition operation on two values. So that is written over here. The plus operation or the addition arithmetic operator can be used to add together two values, or a variable and a value, that is over here. A variable and a value is getting added, or we can also add a variable to another variable. Let me show an example of that too. Int a equal to 2 and int b equal to 3. If I do int c equal to a plus b, what will be the output? The output will be 5. What will be the output? The output will be 5. Here two variables are getting added by the addition arithmetic operator. So a means 2 and b means 3. These two values, 5, 2 and 3 will be giving 5, and this 5 will be stored onto the variable c. All right, so those are very easy and basic parts. I don't think I need to discuss about it much. So let's move on to the next slide, arithmetic operators. Now what are the arithmetic operators in Java? There are several arithmetic operators: the plus, addition, subtraction, multiplication, division, modulus, increment, and decrement. I don't think I need to discuss about plus, minus, and multiplication. Those are very easy. Suppose 5 plus 3, what will be the output? The output will be 8. So 5 minus 3, the output will be 2. 5 into 3, the output will be 15. I don't think I need to discuss about this tree. But I will start discussing from division operator. This is very important. Why this is important? Suppose I am writing a equal to 100 and b equal to 3. If I do c equal to a by b, a means what? 100, and b means what? 3. 100 by 3. What will be the answer? What will be the answer? Let's try to divide 100 by 3. If we divide 100 by 3, 3 into 33 will be 99, and the remainder will be 1. Now, what will happen to the remainder and what will happen to the quotient? In division operator, only the quotient part gets stored. So, the 33 value will be getting stored. 33 value will be getting stored onto the variable c, but this remainder 1 will be getting ignored. This remainder 1 will be getting ignored. Alright, so in division operator, the remainder is ignored and only the quotient part is stored. And the next one is the modulus operator. It is shown with the help of a percentage sign, but we call it modulus operator. What happens in a modulus operator? If I take the same two values, and if I try to do d equal to a mod b, a mod b means a modulus b, 100 modulus 3, what will be the output in this case? The output will be 1. Why? Because it stores the remainder. The remainder after the division operation is done is stored while we use the modulus operator. So 100 modulus 3, what is the remainder? If we divide 100 by 3, the quotient is 33 and the remainder is 1. That remainder is stored while we are using the modulus operator. So the division operator stores the quotient and the modulus operator stores the remainder. All right. So let's take another example. Let's take another example. Suppose we have written x equal to 50 and y equal to 4. Now if we try to do 50 by 4, what will be the output? And suppose if we try to do 50 mod 4, then what will be the output? Tell me. If we try to do 50 by 4, what will be the output? The output will be how much? 12. Why? Because when we are dividing 50 by 4, 12 4 is a 48 and remainder is how much? 2. So this 12 is the output because the division operator stores the quotient part. So 12 is getting printed over here. And when we are doing 50 modulus 4, the modulus operator does what? The modulus operator stores the remainder part. So when we are doing 50 mod 4, the value 2 will be getting printed. I think it is clear now. But let me discuss another thing, which is the most asked question. If I reverse the case, that means suppose I'm writing m equal to suppose 25 and n equal to 30, and if I do d equal to m by 10, m by n, what will be the answer? And if I do equal to m mod n, what will be the answer? Can any of you tell? D means what? D equal to m by n. M by n means what? 25 divided by 30. Then what will be the answer? And here 25 modulus 30. Then what will be the answer? In case of 25 by 30, the answer will be 0. Why 0? You are trying to divide 25 by 30. 30 ones is 30, but that is greater. Can we divide it? No, but 30 zeros is 0. So the quotient will be 0. And in case of 25 mod 30, the answer will be 25. Why? Because in while we are dividing a smaller number by a larger number, the remainder is the smaller number itself. The output or the answer is the smaller number itself. So whenever we are dividing a smaller number by a larger number, the output is the smaller number itself in case of modulus operation. But in case of division operation, whenever we are dividing a smaller number by a larger number, the output or the answer is 0. Why? Because we cannot divide it. So 25 by 30 will result into 0, but 25 mod 30 will result into 25. Alright. Now if I question you again, suppose I have given two values, a equal to 3 and b equal to 5. Tell me the answer of c equal to b by a, d equal to a by b, and e equal to a mod b. Tell me what will be the output. At first, c equal to how much? B by a. B by a means 5 by 3. 5 by 3 is how much? 3 ones are 3. So the quotient will be 1 and remainder 2 will be ignored. So the value of c will be 1. Next comes d equal to a by b. A by means 3 by 5. I told you just now you are dividing a smaller number by a larger number, and the operator here is division operator. So in that case the output is 0. So smaller number divided by larger number, the output will be 0. So the value of d will be 0. And e is what? E is 3 mod 5. You are dividing a smaller number by a larger number, but the operator here is modulus operator. That means the remainder. What will be the remainder? The remainder will be the smaller number itself. The smaller number here is 3. So the value of e will be 3. Alright. So let's move on to the screen and try those examples. Okay, just a minute. This is our third class. So let's name it lecture 3. Let's delete those parts. Hope you have gone through the previous lectures. Then it will be clear to why we are declaring this public static void main. What is this? This is a main function. What is the purpose of this main function and why we need to write it? So what was our target? Our target was to understand division and modulus operator. Now int a equal to, suppose I'm taking the same example, 50, and int b equal to c. If we are doing int c equal to a by b, then what will be the answer? If we are doing int d equal to a mod b, then what will be the answer? And if we are reversing those things, int e equal to b by a, then what will be the answer? And int f equal to b mod A, then what will be the answer? System.out.print system out.print len C. Okay, let me copy it because I need to use this statement again and again. So at first we are doing D, C, D, then E and F. Okay, so let's try to compile it and run it. What is the output? Let's check what is the output over here. 50 by 3, C equal to 50 by 3. 50 by 3 means what? 16 3s are 48. So the quotient is 16 and the remainder is 2. But in division operation or division operator ignores the remainder. Only the quotient is stored. So 50 by 3, 16 is getting stored over here on the variable C. Alright. We are printing C first, so 16 is getting printed. Next, A mod B. I told you just now 50 mod 3 means 50 divided by 3. And what is the remainder? Remainder is 2. 16 3 is a 48, remainder is 250 minus 48 is 2. So modulus operator gives the remainder. So in the variable D, 2 is getting printed. Alright. Next, E. Okay, let me write it. It will be clear too. 50 by 3. 50 by 3. Quotient is 16. And here 50 mod 3. Remainder is 2. Alright. Now B by A. B by A means 3 divided by 50. 3 divided by 50. I told you when we are dividing a smaller number by a larger number. Can we divide it? No, we cannot divide it. So the question will be 0. Check B by A 3 by 50 is printing 0. And the last one 3 mod 50. I also told you about this one. When we are dividing a smaller number by a larger number and when we are using the modulus operator, then the answer will be the smaller number itself. The answer will be the smaller number itself. So the remainder over here is 3. It is a smaller number, 3 mod 50. The smaller number is 3. So the answer is 3 over here. I hope the modulus and division operator is clear to you now. So let's move on to increment and decrement operator. Let's move on to increment and decrement operator. The first and foremost thing which you need to remember is that the increment and decrement operator works only on a variable. Works only on variable. It does not works on values. How? Okay. Suppose I have declared int a equal to 5. If you do plus plus a and then if you print it, if you print a, what will be the answer? The answer will be 6. Why? Because a was containing the value 5 and when you are doing plus plus a means plus plus 5, a is containing the value 5, so plus plus 5 means 6. So a is getting incremented to 6 and when you are printing the value of a, it will print 6. But if you think I will just take and do plus plus 5, you cannot do this. You can perform this plus plus or you can use this operator only on a variable. Alright, and very similar is the decrement operator. Suppose a is containing the value 10. If you try to do minus minus a, it will become 9. When you try to print it, it will become minus minus 10 will become 9. Alright, so those are the increment and decrement operator. Those are very easy. They increases the value by 1. Increment operator increases the value by 1 and decrement operator decreases the value by 1. Let's try to understand this one on our window. Sorry. Alright, let's do int. No need of int. I've already declared a. Let's do plus plus a and print it and print a, and let's do minus minus b and print it. And let me remove all those codes. Compile it, no syntax errors, and run it. Okay. So what is the output? Plus plus a. What was the value of a? 50. Plus plus 50 means the value of 50 is getting incremented or getting increased by 1. So now a is containing the value 51. So a was previously containing 50, plus a means plus 50, 1 is getting added to the value, so 50 becomes 51, and that value is getting stored onto a. So 51 value is getting printed over here. And minus b, same thing, it was containing the value 3, minus b means it is getting decremented by 1, so 3 is getting reduced to 2, and that value 2 is getting stored onto b. So when you are trying to print b after this operator, after this decrement operator, it is showing 2. But if we do one thing, if we try to print the value of a over here, and if we try to print the value of b over here, then you will understand the difference. Let me do it once again. Check. Here, at first, it was printing how much? It was printing system.println a. It was printing 50. It was printing 50. Why? Because the value of a was 50. Then plus a occurred, means the 50 became 51. The 50 became 51. So now it is printing 51. After the plus operator or increment operator is used on the variable a. Similarly, when you are printing the value of b before the operation, it is printing the value 3 because b was containing the value 3. It is printing the value 3. But after the decrement operation, that 3 is getting converted to 2. So when you are trying to print b, it is giving the value 2 as the output. Alright. I hope it is clear now. So these are the arithmetic operators: addition, subtraction, multiplication, division, modulus, increment, and decrement. So the last four are very important for your exams: division, modulus, increment, and decrement. This means these four operators are the most asked in your exam, most asked operators. So try to practice some output based questions. Okay, so let's move on to assignment operators. Assignment operators, equal to, I've already told you, this is very easy also. Int x equal to 10. What it is doing? It is assigning the value. What is the value? 10 over here. This value 10 is assigned to the variable x. That means this value 10 is stored onto the memory location of x. So assignment operators are used to assign values to variables. Alright, so this is very easy. Now plus equal to, minus equal to, asterisk equal to, divide equal to, mod equal to, these five are very similar to each other. But suppose I have written x equal to 5. Now if I try x plus equal to 5, what will this mean? This means x equal to x plus 5, means whatever the value there was with x, what was the value? 5. Along with that, another 5 will get added. 5 plus 5 will become 10. If I do x equal to 2, and if I write x plus equal to 3, that means x equal to x plus 3, means whatever the value there was with x was containing the value 2, 2 plus 3 will become 5. So this is how minus equal to, asterisk equal to, divide equal to, and modulus equal to will work. Suppose x equal to 10, if you do x minus equal to 3, what will happen? X equal to x minus 3. So x was containing the value 10, 10 minus 3 will become 7. So x will contain the value 7. If you do x asterisk equal to 5, and x was containing the value 10, that means x equal to x into 5, 10 into 5 will become 50. If you do x by equal to 5, x was containing the value 10, that means x equal to x by 5. So 10 by 5 is 2. And at last, x mod equal to 5. Again, if you do x by 5, x mod 5, 10 mod 5 is how much? 0. When you divide 10 by 5, what is the remainder? The remainder is 0. So the plus, minus, asterisk, division, and modulus, these operators I have already discussed. The equal to sign is added with those operators. That means those are becoming assignment operators. After performing the calculation, after performing the addition calculation or the addition operation, then it is assigning the value. So those are known as assignment operators. But if you want to understand it in depth, let's try it on the window again. But before that, let's try with another example. Suppose I'm writing x equal to 16, and you have given me x minus equal to 8. What will happen? What will happen? This minus equal to will mean x equal to x minus 8, means whatever the value there was previously lying with x, that value, from that value 8 will be subtracted. So 16 minus 8, 8. This is the final answer, and this final answer 8 will be assigned to the variable x. So both the subtraction operation and the assignment operation is happening over here. x minus equal to 8 means x equal to x minus 8. So you need to remember this. Plus equal to 3 means x equal to x plus 3, x minus equal to 3 means x equal to x minus 3, and similarly x by equal to 3 means x equal to x by 3. Those are very easy. So let's try it on the window, then it will be more clear to you. And you also try to run those examples on your device. Just seeing the lecture won't help you. You need to practice also. Suppose int a equal to 30. Let me a plus equal to 5. Let me print it. System.println a. Next, let me do, suppose int b equal to 30 again. B minus equal to 5. Let me print b. Now int c equal to 30 again, and let me do c asterisk equal to, means multiply. So let me print c, then int d equal to 30 again, and let me do d by equal to 5. Println d, and at last int e equal to 30, and let me do e modulus equal to 5, and let me print it. So what will be the output? 30 equal to 30, a plus equal to 5 means a will be getting the value 30 plus 5, because 30 was previously assigned to a. A will be getting the value a plus 5, a plus 5, that means 30 plus 5, isn't it? A equal to a plus 5 means a was previously getting the value 30, 30 plus 5, 35 will be getting stored onto a. Similarly, b will get the value 30 minus 5, 30 minus 5, 25 will be getting stored onto b. C will be getting the value 30 into 5, 30 into 5 is 150. So C equal to C asterisk 5. That means C will get the value 30 asterisk 5. Similarly, D equal to 30 by 5 means it will get the value 6, and E will get the value 30 mod 5. 30 mod 5 is how much? 0. 30 mod 5 is how much? 0. Because when you try to divide 30 by 5, the quotient is 6 and the remainder is 0. Let's try to compile it and run it. Okay, so let's check the outputs. See, 30 plus 5, 35 is getting printed. 30 minus 5, 25 is getting printed. 30 into 5, C asterisk equal to 5, 150 is getting printed. 30 by 5, D by equal to 5, 30 by 5, quotient 6 is getting printed. And at last, 30 mod 5, the remainder is 0, so 0 is getting printed at last. So what does this mean? This means that E mod equal to 5, it can also be written as E equal to E mod 5. So at first E is containing the value 30, 30 mod 5 is how much? 0. After performing the calculation of modulus calculation, the remainder 0 is getting stored onto the value E. So 30 mod 5, the output is how much? 0, and that 0 is getting stored onto the variable E. I hope it is clear now. So these are the few operators, first few operators, assignment operators. The next is AND equal to or equal to, or equal to, and left shift and right shift. I will discuss it at the end of the lecture today, because before that I need to discuss the bitwise operators with you. Okay, so next is comparison operator. Comparison operator helps us to compare between two things, between two values or between two variables. Suppose we are writing 3 greater than 5. Is this true or false? This is false. Is 3 greater than 5? No. If it is no, then it will return false, and if it is true, suppose 5 greater than 3. Is this true or false? Yes, this is true. Then it will return true. So it can return only in two values, either 3, either true or false. Sorry, it can return only two values, either true or false. These are the Boolean values. I have already discussed the Boolean data types, true and false, in last day's lecture. So 3 less than 5, 3 greater than 5, that is false. 5 greater than 3, that is true. So what are the comparison operators? Equal to, double equal to. That means suppose I have stored x equal to 3 and I have also stored y equal to 3. If I try to do x double equal to y, what will it print? It will print true. Why? Because 3 double equal to 3. Yes, 3 is equal to 3. So it will print the value true. But if I do x equal to 3 and y equal to 4, and then I try to do x double equal to y, that means 3 double equal to 4. 3 is equal to 4? No. So it will print the value F or false. Alright. Then comes not equal to. Not equal to means, suppose I have written x equal to 3 and y equal to 4. Then if I do x not equal to y, what it will return? It will return true. Why? Because 3 not equal to 4. Yes, it is true. Is 3 equal to 4? No, 3 is not equal to 4. So this statement is true. But if I do x equal to 4 and y equal to 4, and then I use x not equal to y, what will be the output? The output will be false. The output will be false. Why? Because 4 not equal to 4. This is a false statement. 4 is equal to 4. So how can we do 4? How can we say 4 not equal to 4? So the output will be false. Let's try to run it. Let me declare two variables int b equal to 30 also, and system dot out dot println. The first operator is a double equal to b, and the second operator is a not equal to b. What values I have used over here? I've used 3. If I use 3, that will be easier for you to understand. Okay, let's compile it and run it. Check what is the output. 3 double equal to 3. Yes, 3 is equal to 3, so the output is true. 3 not equal to 3. What it means? It is saying that 3 is not equal to 3, but it is a false statement. 3 is equal to 3. How can you say that 3 not equal to 3? So it is printing false over here. It is printing false over here, isn't it? If I make another change, if I do suppose int x equal to 4 and int y equal to 3. Now if I try to print system.out.println x not equal to y, and if I try to do x double equal to y, let's guess what will be the output. X not equal to y, 4 not equal to 3. Yes, 4 is not equal to 3, so it will return true, because 4 is not equal to 3, and here 4 double equal to 3. Is 4 equal to 3? Is 4 and 3 equal? No, 4 and 3 is not equal, so it will print false, isn't it? Let's try to compile it and run it again, then it will be clear to you. Check what are the last two answers: true and false. But it is printing true and false. X not equal to y, 4 not equal to 3, 4 not equal to 3. Yes, that is true, 4 not equal to 3. But 4 double equal to 3. Here the values are different, but we are using the double equal to operator. Is 4 equal to 3? No. So it is printing false. Alright. Then greater than and less than. These two are very easy. I don't think I need to discuss it much. If I've already discussed this once. The last one is greater than equal to and less than equal to. What? Greater than equal to and less than equal to. Now suppose I've written 5 greater than 3. This is what? This is true. But if I write 5 greater than 5, what will be the output? The output will be false. Why? Because 5 is not greater than 5. 5 is equal to 5, isn't it? But if I do 5 greater than equal to 5, then the output will be true again, because greater than equal to means it is comparing, it is checking both. Is the first value greater than the second value? If not, is the first value equal to the second value? Is the first value greater than the first value? No. Then it will again check, is the first value equal to the second value? Yes. If any of the condition is satisfied, then it will return true. All right, just a minute, let me switch on charger. So 5 greater than equal to 5, it will return 2, but 5 greater than 5 will return false. Similarly, if we do 3 less than 3, what it will do? It will return false, because 3 is not less than 3. But if we do 3 less than equal to 3, it will return true. Why? Because it will check two conditions: less than or equal to. Is 3 less than 3? Is the first value less than the second value? No. Then it will move on to the second condition, equal to. Is the first value equal to the second value? Yes. So if one of the condition is satisfied, it will return true. Alright. So let's try with those examples on the screen. int what happened int a equal to 3, int b equal to 3 again, system dot out dot println a greater than b, system dot out dot println a greater than equal to b. So what will be the output? 3 greater than 3. The output will be false. Why? 3 is not greater than 3. But the next condition is 3 greater than equal to 3 or not. Greater than equal to. Yes, 3 is equal to 3. So it will return true. Alright. So let's try another one. Int a equal to 5. Int b equal to 6. If we, oh sorry, I've already declared a and b. So let's do it c and d. If we do system dot out dot println c less than d, and if we do system dot out dot println c greater than d, so what will be the output over here? C less than d, 5 less than d, 5 less than 6. Yes, 5 is less than 6, so this will return true. And what will the output over here? C greater than d, 5 greater than 6. No, 5 is not greater than 6, it will return false. All right. Let's make another variable int e equal to 5. And the last one, if we do system dot println c less than equal to e, is 5 less than 5? No, but 5 is equal to 5, so this will also return true. All right, so let's check the last 5 outputs after compiling and running it. Let's run it. Right, now let's move on to the screen. Let's check the last 5 outputs. False, true, true, false, true. False, true, true, false, true. All right, false, true, true, false, true, true, false, true. It is also false, true, true, false, true. So I hope it is clear now. Now, sorry, just a minute. Let's move on to the next operators. What are those? We have already discussed about all the comparison operators. Those are very easy. But the next slide is of the logical operators. Now, before discussing about logical operators, you need to understand that these are very similar to the previous one. True and false values are used over here also. That means, suppose I'm telling you x greater than 5 and x greater than 3. Now x is containing the value 10. 10 greater than 5. Is 10 greater than 5? Yes. And 10 greater than 3. Is 10 greater than 3? Yes. Then it will answer true. Then it will answer true. Why? Because both the conditions are satisfied. So logical and means what? It returns true if both the conditions or both the statements are true. Now, suppose 10 less than 20 and 10 less than 30, then it will return true. That is the work of logical and. But if you say I want to do like this, I want to write this condition 10 less than 20 and 10 less than 5, then it will return what? It will return false. Why? Because the first statement is true, 10 is less than 20, but is 10 less than 5? No, 10 is not less than 5, so it will return false. All right, 10 less than 20 is true, but 10 less than 5 is not true. So we have already discussed that if both the statements are true, then only it will return true. But here one of the statement is false, so the answer will be false. Now if we move on to logical or, can you guess what will the answer if I write the same statement 10 less than 20 or 10 less than 5? What will be the answer over here? The answer over here will be true, even though both of them are same. Just now I've written 10 less than 20. 10 less than 20 is true, but 10 less than 5 is false. The answer would have been false because 10 less than 5, here it is a false statement. No, in logical or, here it returns true if one of the statement is true. That means if one of the statement is true out of these two, then only it will return true. So if another statement, suppose x equal to 5 and it is written 5 greater than 3 or 5 greater than 10, here also it will return true. Why? Because 5 greater than 3, one of the statement is getting satisfied. This is true, but this is false. Is 5 greater than 10? No. But since one of the values is true, the answer will be true. But if you try to do the same thing, 5 less than 5 greater than 3, and 5 greater than 10, the final answer will be false. Why? Because this will result as true, but this will result as false. 5 greater than 10, this is a false value. But we already know that in logical and both the statements is needed to be true. So the answer will be true only in that case when both the statements are true. But here one of the statement is false, so the answer will be false. All right. Next, the last one is logical not. Logical not means whatever you will getting the answer, it will reverse it. It reverses the result. Return false if the result is true. If the result is true, then it will return false. And if the result is false, then it will return true. If the result is false, then it will return true. And if the result is true, then it will return false. Alright. So let's try to understand this with the help of a code. You won't understand this in details because we need to use if else statement over here. Let's try it as far as you can understand. If a less than 10 and a less than 30, system.out.println. Okay, no need to use if statement over here. Let's try to do this. Directly print it. It will be easier for you to understand. Alright. So we have used the AND over here. Let's try to use OR. Let's try to use OR. System.out.println a less than 10 or a less than 30. Next, let's change something. System.out.println a less than 10 and then a less than 5. And similarly, let's do this a less than 10 or a less than 5. Now tell me what will be the output in these four cases. A less than 10 and then a less than 30. A is 3. A is containing the value 3. So 3 less than 10, yes. 3 less than 30, yes. So both the statements are true. And in AND operation, if both the statements are true, then only it will return true. So the output over here will be true. Next, 3 less than 10, yes. 3 less than 30, yes. In OR operation, if one of the statement is true, then only it will return true. But here both the statements are true. So no problem. This will also return true. 3 less than 10 or 3 less than 30, yes. This is all true. Now 3 less than 10, yes. 3 less than 5, okay, I've made it 5, sorry. Let's make it 2. 3 less than 10, yes. 3 less than 2, no. 3 is not less than 2. So this part is true, but this part is false. But in AND operation, in logical AND, both the statement needs to be true. If one of them is false, then the answer will be false. So this part is false, so the answer will be false. Alright. And here again, 3 less than 10, yes. 3 less than 2, no. This part is false. But in logical OR operation, if one of the statement is true or if one of the condition is true, then only the output will be true. This part is true, but this part is false. So no need of this false part because it was true over here. So the answer will be true. The output will be true. Alright. And the last one, let's try to do one thing. The last result what we were getting. The last result what we were getting the true result in this case, a less than 10 or a less than 2, we were getting true if we put a not sign or not operator before that. So this part will execute and return the value true, and not of true, it will become false. I told you logical not reverses the value. This part will return the value true, not of true will become false. So this will print as false. All right. So Let's try to compile it and run it. Just a minute. Yeah. Let's check the last few values. True, true, false, true, false. True, true, false. Check. True, true, false. True, false. True, false. These are the last values. True, true, false. True, false. So our output matched with the output the compiler is providing. So a less than 10 and an a less than 30, when both the conditions are getting satisfied, then only it will return true, because that is the behavior of logical and. But here one of the condition is not getting satisfied. This is true, this is true, but this is false. So if one of the statement is false, it will return false. Next, what is the behavior of logical or? If one of the statement is true, then it will only return true. Here a less than 10 is true, so directly it will print true. A less than 10 or a less than 2, here this part is false, but doesn't matter, this part was true, so it is printing true. And what is the behavior of not operator? What is the behavior of not operator? Whatever value we will get, if we put a not sign before that, the value will get reversed. So in this condition we were getting the answer as true. If we put a not sign before that, the value will be reversed. True is getting converted to false. So I hope it is clear now. And one thing, this is like, I don't expect it to be given in a ICC examination. Still, I'm telling. Suppose here it is written 10 less than 2 and 10 less than 30. Now, the answer will be false. Why false? You know that 10 less than 2, this is a false part and this is a true part. But you need to remember one thing, that if the first statement is executed as false when we are using the logical AND operator and the first condition we are getting false, the compiler does not even look for the second condition. The compiler does not even checks for the second condition. Because why? In logical and, if the first condition is false, then only it will return false. Both the statements or both the conditions are needed to be true to return true. So when the first condition is evaluated as a false statement or false condition, then it does not even check for the second part. It will stop its execution and return false over here only. All right. So in some future outputs, in some future classes, we will discuss about some outputs. There we will discuss about this condition. Like, you need to remember this case, that when the first condition is evaluated as false, then the second condition is not even checked. But is this the case same for OR operation? No. OR operation checks for both the statements, because if any of the statement is true, then only it will return true. So 10 less than 2, here it will get false, but it cannot stop its checking, because it will need to check over here also. Here it is getting true, so it is returning true. But if it would not have checked over here, then what will happen? It will return false, but then that will be an error in the program. So in OR operation, both the conditions are checked. Even if the first condition gives a false condition or returns false, then also both the conditions are checked. But in logical AND operation, if the first condition is returned as false, then it does not move on, or the compiler does not proceed to check for the second condition. If the first condition is returned false, then it stops checking and returns false as an output. Returns false as an output. I hope it is clear now. So those are the logical operators. Next comes the bitwise operators. This is a very important part of the class, the last few minutes of the class, and you need to be concentrating very much, because this is very, very important. So there are four bitwise operators: the AND, OR, NOT, and XOR. This one is AND, this one is OR, this one is XOR, and this one is NOT. So what are the functions of those? Let's check. Suppose we have two binary numbers, 0 and 1. I already told you in the first class. What are the possible combinations? 0, 0, 0, 1, 1, 0, and 1, 1. Now what will happen in AND operation? In AND operation, if both the inputs are high, then only it will return high, or it will print the output as high. Here the inputs are low. Here one of the input is low. Here one of the input is low. Here both the inputs are high, then only it will return high. If both the inputs are high, then the output is high. One of the input is low, then the output will also be low. One of the input is low, then the output will also be low. Here both the inputs are low, so the output is low. So AND operator goes very similar to the multiplication operator. Look, 0 into 0 is 0, 0 ones are 0, 1 0 is 0, 1 ones are 1. So I hope you will remember the AND operator. This is very important. If both the outputs are high, then only the answer will be high. Alright. Next, the OR operator. OR operator. Again, the four combinations 0, 0, 0, 1, 1, 0, and 1, 1. So here you need to remember that if one of the input is high, then only the output will be high. Here, one of the input is high, the output is high. One of the input is high, the output is high. Both the inputs are high, so no problem. One of them is high, so the output will be high. But here, both the inputs are low, so the output will be low. Alright, if one of the input is high, then the output is high. So I'm writing over here, if one input is high, then output will be high. High means 1 and low means 0. And in AND operation, if both input are high, then only output will be high. Alright. So this is the AND operator and this is the OR operator. Very important. Alright. Now let's move on to the XOR operator. Let's move on to XOR operator. Again the four combinations 0, 0, 0, 1, 1, 0, and 1, 1. So 0, 0, 0, 1, 1, 0, and 1, 1. Here you need to remember that if both the conditions or both the inputs are same, then the output will be low. 0, 0, both are same, the output is low. 1, 1, both are same, the output is low. But when the inputs are different, then the output is high. 0, 1, 0 and 1 are different to each other, so the output is high. 1 and 0 different, so high. So what happens in XOR? Both input same, then the output will be low. Alright. And if both input different, then the output will be high. So if the inputs are different, then the output will be high. If the inputs are same, then the output will be low. So these are the AND, OR, and XOR operators. And NOT operator is very easy. NOT operator is very easy. It turns 0 into 1 and 1 into 0. No need to understand this. 0, it turns 0 into 1 and 1 into 0. Now what are the use of these operators? Suppose I am writing 5 and 7. Now what is the binary representation of 5? I've already discussed 101. What is the binary representation of 7? 111. If I try to do 5 and 7, 101 and 111, what we are doing, we are performing AND operation. So 1 and 1, both the inputs are high, output will be high. 1 and 0, one of them is low, so the output will be low. 1 and 1, again the output will be high because both the inputs are high. So 101, again it is coming 101. So 101 we already know is the binary representation of 5. So 5 and 7 will return as 5. Alright, 5 and 7 will return the value as 5. Next, if we try to do 5 or 7, 5 is 101, 7 is 111. If we try to do the OR operation, 1 or 1, both the inputs are high, output will be high. 0 and 1, both the one of them is high, so the output will be high. 1 and 1, both the inputs are high, so the output will be high. So again we are getting 111. 111 we know is the binary representation for 7. So 5 or 7 will return as 7. Alright. And if we try to do 5 XOR 7, let's try to do, this is very interesting. 101 and 111, we are performing the XOR operation. So 1 and 1, both the inputs are same, so the output will be low. 0 and 1, both the inputs are different, so the output will be high. 1 and 1, both the inputs are same, so the output will be low. Both the inputs are same, so the output will be low. So 0, 1, 0. 0, 1, 0 is the binary representation, but the decimal number will be what? 2 to the power 2, here 2 to the power 1, here 2 to the power 0. 2 to the power 2 into 0, something into 0 is 0, plus 2 to the power 1 is how much? 2. 2 into 1 will be 2. 2 to the power 0 is how much? 1. 1 into 0 is 0. So 0 plus 2 plus 2, 0 plus 2 plus 0 is 2. So 0, 1, 0 is the binary representation of 2. So 5 XOR 7 will return 2. Let's try to do this on the screen. 5 and 7, 5 or 7, and 5 XOR 7. Then it will be clear to you. Int a equal to 5, int b equal to 2. Let's do A and 5, sorry, A and B, 5, B will be 7. A and B. Next we will do A or B, and at last we will do A XOR B. A XOR B. Let's try to compile it and run it. Check the outputs. 5 and 5. Sorry, 5 and 7. The answer is printing as 5. 5 and 7. What we have discussed over here. 5 and 7. The answer was 5 over here too. Next. Sorry, just a minute. 5 or 7. 5 or 7, the answer is getting printed as 7, and 5 or 7, the answer is getting printed as 2. So 5 or 7 is 7 and 5 or 7 is 2. Let's check. 5 or 7 is 7 and 5 or 7 is 2. So our answer is matching with what the Java compiler is printing on the screen. So this is how the bitwise operations take place. And, or, and XOR operation. And NOT operation is very easy, just the bits will get reversed. Now let me discuss the last two, the left shift and the right shift. The left shift and the right shift. Now what will happen? Suppose I am writing a equal to 5 and then I am doing left shift 5. And suppose I am doing b equal to 10, I am doing right shift b. What will be the answer? What will be the answer? Let's run on the window first. Let's check the output. What will be the value of left shift 5 and right shift 10? Suppose, remove this. Okay, let's make b as 10 and remove this statement. Let's do left shift a. See, here it is throwing an error. Why it is throwing an error? Why it is throwing an error? Can you guess? What will be the result? Can we do it as a like this? Then also it is throwing an error. So what we need to do? We need to put a number over here. What does this mean? I will explain it to you. Wait for a minute. So let's try to do right shift B. Right shift B. See, it will again throw an error. So we need to put a number over here also. So if we are doing A left shift 1 and if we are doing 1 right shift B, let's compile and check the output. See, here it is printing A left shift 1. Here it is printing 10 and 10. 1 left shift, 1 right shift 10. Here it is printing 0. What is happening? Let's understand. Alright. See, here it is written used to shift bits to the left. So when we are doing left shift, when we are doing, just a minute, what we have done on the screen, A left shift 1, A was 5. So we are doing 5 left shift 1, 5 left shift 1. Now what is the binary representation of 5? The binary representation of 5 is 101. 101 left shift 1 means we are shifting the position of these bits by one place. Means suppose this was the first position, this was the second position, this was the third position, and all the other positions were 0, filled with 0. But we are shifting the position by one place. We are shifting the position by one place. So this 1 is coming over here, this 0 is coming over here, this 1 is coming over here, and this position is getting filled with a 0. This 1 came over this position, this 0 came over this position, this 1 came over this position, and this position is getting filled with a 0. Now what is the output? After shifting by 1, the output is 1010. The output is 1010. So 1010, that is a binary representation. If we convert it into decimal, what will the output? This will be 2 to the power 3, this will be 2 to the power 2, this will be 2 to the power 1, this will be 2 to the power 0. So 2 to the power 3 into 1, 0 we don't need to consider, plus 2 to the power 1 into 1, 2 to the power 1 into 1, 2 to the power 3 means 8, 8 into 1 8, plus 2 to the power 1 means 2, 2 into 1 is 2, so 8 plus 2 is 10. So 5 left shift 1, 5 left shift 1 is printing the value 10 on the screen. Alright, so this is how the bitwise operator, the shift operators work. Used to shift bits to the left. So 5 left shift 1, this one value we need to put. 1 means how many positions, 1 means how many positions we are shifting the value, we are shifting the bits to the left, we are shifting the bits by 1 position. So left shift 5, this will mean what? This will mean that suppose a equal to 10, so a left shift 5, this will means that the numbers, what are the numbers? The 10, if we write 10 in binary, it will be 1010. Left shift 5 means we are shifting the bit positions by 5 places. But generally, we do our calculations with only one bit position shift, only one bit shift. So try to remember with left shift 1, 1010. If we again left shift, if we again try to do, then what will be the answer? It will again get shifted by 1. Here it will also get shifted. So 1 will come over here, 0 will come over here, 1 will come over here, 0 will come over here, and another 0 will be getting filled. I think you're getting difficult to understand. Suppose 1010. Here all the other positions are 0. All the left positions are 0. Now 1 is coming over here, 0 is coming over here, 1 is coming over here, 0 is coming over here. Now this position is empty because this 0 came over here. So in this empty position, another 0 is getting filled. Another 0 is getting filled. So what is the final output? 1. Here 0. Here another 1. Here this 0 and here another 0. So 10100. 10100. So let's try to do. This is 2 to the power 4, this is 2 to the power 3, this is 2 to the power 2, this is 2 to the power 1, this is 2 to the power 0. So we only need to consider the one part, we need to ignore the zeros part. So 2 to the power 4 plus 2 to the power 2. 1 into 2 to the power 4 plus 2 to the power 2 into 1. So 2 to the power 4 is how much? 2 to the power 4 is 16, plus 2 to the power 2 is how much? 2 to the power 2 is 4. 16 plus 4 is 20. So when we are doing 10 left shift 1, that means the output is 20. Can you notice one thing? At first 5. When we were doing 5 left shift 1, then the answer became 10. When we did 5 left shift 1, then the answer became 10 over here. Then the answer became 10 over here. And when we are doing 10 left shift 1, then the answer is becoming 20. So every time it is getting multiplied by 2. 5 into 2 become 10. 10 into 2 become 20. So left shift 1 means it is multiplying the value 2 to it. It is multiplying the value 2 to it. So let's try and do 10 left shift 1. Let's try to do, remove this. Suppose let's make it 10 and let's try to do 10 left shift 1. Let's try to find the answer. Compile it and run it. Check. 10 left shift 1 is printing 20. I hope now it is clear to all of you. 10 left shift 1 is printing the value 20. Alright. So this is how the bitwise shift operators work. This is left shift operator and this is right shift operator. And this is AND, OR, XOR and NOT. Now let's get back to the assignment operators. Now it will be very easy for you. AND equal to, OR equal to, XOR equal to, left shift equal to and right shift equal to. Suppose we have x equal to 5, and if we try to do x and equal to 3, what will be the output? That means x will be first written as x and 3. So at first x and 3 will be calculated, then the final value will be stored onto the value variable x. So 5 means what? 101. 3 means how much? 3 means 3 is written as 1 1. So when the bits are different by one position, we put a 0 over here. So in AND operation, you know, if both the bits are high, then only the output is high. 1 and 1 will be high, 0 and 1 will be low, 1 and 0 will be low. So the answer is how much? Answer is 0 0 1. 0 0 1 means here it is 2 to the power 2, here it is 2 to the power 1, here it is 2 to the power 0. We don't consider these two bits. Here we will only do 1 into 2 to the power 0. 2 to the power 0 means 1. 1 into 1 is 1. So x and 3 will give us 1. So x equal to 1. That means the 1 is the final result, and that result will be getting stored onto the variable x. So if x equal to 5 and x and equal to 3, then it will be, the final value will be x equal to 1. Similarly, or equal to, not zor equal to, I don't think I need to show all of this to you again, because I have already discussed them in the bitwise operators. Here x left shift equal to 3, or if I do x left shift equal to 1, that means it can be written as x equal to x left shift 1. Suppose x was containing the value 10, so 10 left shift 1, that means 20. The final value of x will be 20. All right, let me show these two examples to you. X5, let me show these two examples, then it will be clear to you. This is the last part of today's lecture. And t a equal to 5. Let me do system.out.println. Okay, just a minute. Let me do a and equal to c. System.out.println a. And let me do int b equal to 10, b left shift equal to 1, and system.out.println b. Let's try to compile it and run it. Check what is the output. 5 and 3. 5 and 3 is printing 1, and 10 left shift 1 is printing 2. Because b equal to 10, b left shift equal to 1 means b equal to b left shift 1. So 10 left shift 1 is 20, and that 20 is getting stored onto the variable b. And a and equal to 3 means a equal to a and 3. 5 and 3 is 1, and that 1 is getting stored onto the variable a. So that is what we had discussed. 5 and 3, it will give us 1. 5 and 3 was giving us 1, and x left shift equal to 1 means x equal to x left shift 1, that will give us 20. So this is how the assignment operators are working, and we can use the plus, minus, asterisk, division, modulus, and operator, odd operators, or operator, and left shift and right shift operators along with them. So these are the operators in Java: bitwise operators, logical operators, comparison operators, assignment operators, and arithmetic operators. So this lecture is very, very important. I hope it is clear to you now. If you have any doubt, I hope there will be many doubts and many questions after this lecture. Please ask in the comment section. I will be clearing all of your doubts. And this lecture is one of the most important lecture in the whole course, because this is the basic thing we need to learn, we need to understand while we will be writing programs. So yeah, that's all for today's class. Please do like, share, and subscribe the channel, and share it with your friends so that it can help and it can reach more other people who are financially unstable and who need support. All right, so let's end today's session today.